All right, so section 3 is yours is to reason why, fraction by fraction division, which is what we've been working on. Learning goals here are to model the division of fractions using area models and on a number line, compute and interpret quotients of fractions and interpret remainders, divide with mixed numbers. Some key terms: complex fraction, reciprocal, multiplicative inverse property. In the warm-up, use benchmark fractions to estimate each product. Okay, 2 5/6 is close to 3. 3 1/8 is close to 3. 3 times 3 is 9. 3 8/9 is close to 4. 2 5/7 is close to 2.5. 4 times half of 4, which is 2, or 4 plus half of 4, which is 2, is going to be 10. 9 6/7 is close to 10. 4 1/5 is close to 4. 10 times 4 is 40. 6 4/7 is close to 6.5. 2 1/9 is close to 2. 6.5 twice is going to be 13. Okay. Doesn't say I have to solve these, so I don't have to solve these. You've learned how to multiply and divide with whole numbers and positive rational numbers. How can you apply what you know about operating these numbers to understand how to divide two fractions or mixed numbers? Okay. All in the fact family. Write the multiplication division fact family for each rectangular array. Well, this is 7 times 9 equals 63. I could rewrite this as 9 times 7 equals 63. It's multiplication and division, so the division facts would be 63 divided by 9 equals 7, or 63 divided by 7 equals 9. I can do the same thing for 2 and 3. 2 times 7 is 14. 7 times 2 is 14. 14 divided by 2 is 7. 14 divided by 7 is 2. 4 times 7 is 28. 7 times 4 is 28. 28 divided by 4 is 7. 28 divided by 7 is 4. The side lengths for each fact family, which numbers represent the side lengths? Well, this is 4 and 7. This is 2 and 7. This is 9 and 7. The side lengths are the factors. Okay, which numbers represent the area? The area is the product. 4 times 7 is 28. 7 times 2 is 14. 7 times 9 is 63. Okay, so the product is the area there. Activity 3.1, fractional fact families. Collect all the diagrams you sorted in the lesson thinking rationally. Just like fact families for whole number area models, you can also write multiplication division fact families for models involving fractions. Consider the model shown. The area represents the fraction 1/20th because one rectangle is shaded in the total of 20 total unit rectangles. The height of the shaded rectangle is 1/5 of the height of the model. 1, 2, 3, 4, 5. The width of the shaded rectangle is 1/4 of the width of the model. 1, 2, 3, 4. So the shaded area of the rectangle represents the product 1/5 times 1/4 equals 1/20th. Write the multiplication division fact family for the model. So we could have 1/5 times 1/4 equals 1/20th. And flip that around, 1/4 times 1/5 equals 1/20th. And we can do the division problems. 1/20th divided by 1/5 equals 1/4, or 1/20 divided by 1/4 equals 1/5. Describe how the model shows the division of fractions. You can get the division answer from the fact family. Okay. And then for 3, it says write multiplication, division, fact families with fractions for the remaining diagrams that you sorted. Show your work. All right. So we had 3/4 times 3/6 equals 9/24, or flip that around, 3/6 times 3/4 equals 9/24. And then we can do the division. 9/24 divided by 3/4 equals 3/6, or 9/24 divided by 3/6 equals 3/4. Okay, and so these were these cards from the very first section here. And then another one that they did show was 1/3 times 3/5, and that equals 3/15. Or flip those around, 3/5 times 1/3, and that equals 3/15. Or 3/15 divided by 3/5 equals 1/3. Or 3/15 divided by 1/3 equals 3/5. Okay, and so those were those cards that we had for the other day. Activity 3.2, fraction strip models. You can also use fraction strip models to represent fraction division. For example, this model shows 3/4 divided by 1/4. The division expression asks how many 1/4 are in 3/4. What is the quotient of 3/4 divided by 1/4? Well, it is going to be 3. The quotient will be 3. And then the answer. 1/4 fits into 3/4 3 times. Okay. All right. Then write a sentence to describe what each division expression is asking. Then draw a fraction strip diagram to represent the division problem. Finally, calculate the quotient and write a sentence to describe your answer. So if I have this, I would have 3 halves. So 2 halves are whole, and then I would have my other one. Okay. 1/4, well, the 1/4 would kind of go okay. And so these are the 1/4. This is the 1/2, 1/2, 1/2, 1/2 to get 3 halves. And then I would say how many quarters are in 3 halves would describe this. And then my answer, 1, 2, 3, 4, 5, 6, my quotient would be 6 here. Okay. And I can do the same thing for the other 2. I take 1/2. And then 4/8 is the same. So this would be 1/8. And then I would think of how many eighths fit into 1/2. And then my quotient is going to be 4 for this one. And then last but not least, I have 3/4. And then I have 1/8. And this is my 1/8. This is my fourths, 1/4, 1/4, 1/4. And then how many eighths? Fit into 3/4. Okay. And then 1, 2, 3, 4, 5, 6. And my answer for that one, my quotient for that one is going to be 6. All right. How can you check each of your answers in question 3? To make sure you are correct, explain your reasoning. Okay. Well, you use division, so you could use multiplication to check the answers. Okay. Then Mason has 2/3 of a foot. Okay, 2/3 of a foot. Well, it's 12 inches. Break that into 3 parts. It would be 4. 2/3 would be 8 inches. Okay. He needs to divide the ribbon into 1/6 foot pieces. How many pieces can he cut from the ribbon? All right. So, let's see here. If I was to take 2/3, so 1/3 and 1/3, that's to break it into sixths. 2/6 is 1/3, so that's 1/6, that's 1/6, that's 1/6, and that's 1/6. And so he would have that many pieces. He would have 4 pieces. Okay. And so 1, 2, 3, 4. That would be him breaking it up into sixths. Activity 3.3, dividing across. All right, so now we're going to show you some division ways that we have not been practicing. We want to use KCF, and so they're just showing some other ways that do work. Okay, in the same way that you can multiply across or multiply the numerators and multiply the denominators to determine the product of 2 fractions, you can also divide across to determine the quotient of 2 fractions. Okay, so if I look at my first worked example here, determine the quotient of 7/8 divided by 1/2. So this one works. Okay, a lot of them don't. Divide the numerators, then divide the denominators. 7 divided by 1 is going to be 7. 8 divided by 2 is going to be 4. And so we do get that answer. And if I was going to go through each of these and I was going to say, well, I could do this too, I would get 14/8, which is equivalent to 1 and 6/8, which is equal to 1 and 3/4, which would be the same thing as 7/4. Okay, so you get the same answers here, but this situation works because 8 divided by 2 is equal. All right, and so that works all right, but that only happens very rarely. These are nice to know, and that's why I'm showing them, but I would not use these. I would use what we've been practicing in class. Amy and Sandy used different ways to calculate the quotient, 3/4 divided by 1/3. So Amy first decided to make it so they both had equivalent denominators, a common denominator of 12, and she made equivalent fractions to get to 12. Okay, now that she had common denominators, she was able to make this work. So 12 divided by 12 is going to be 1, and then 9 divided by 4 is going to be 9/4. Okay, and 9/4 is the same as 2 and 1/4 if they're going to switch it into a mixed number. Okay, so you could make common denominators like what you're supposed to do when you add and subtract fractions. However, it becomes kind of a pain in certain situations for sure. Sandy started to show us why we multiply by the reciprocal. And so she decided that I can write this division problem as a complex fraction. That's what this is. That is a complex fraction. Once I write my complex fraction, I want to make sure that I am getting it so the denominator is 1. So I multiply it by the reciprocal of the divisor. I get 1, and then I do get my answer because whatever is on the top is what is equal here. Okay, these are nice to know things, but we need to continue to work on keep, change, flip. Okay. Okay. A complex fraction is a fraction that has a fraction in either the numerator, the denominator, or both the numerator and denominator. Study Sandy's and Amy's methods. Which student wrote complex fractions? Sandy wrote the complex fractions. How are the methods different? How are they alike? Amy got a common denominator. Sandy she wrote a complex fraction and used the reciprocal to make the denominator 1. Okay. Calculate each quotient by dividing across. Write any improper fractions as mixed numbers. Okay. What's weird is I don't see how A works yet. So let me go through this. 3 divided by 1 is 3. 8 divided by 4 is 2. 3 over 2 is 1 1/2. See, these work because they go in evenly. 5 divided by 2 is, see, this one doesn't either. 5 divided by 2 is 5 over 2. 6 divided by 3 is 2. Yucky. 7 divided by 3 is 7/3. 8 divided by 4 is 2. Okay? So I don't like these at all. And so I would want to just remember my keep, change, flip. Okay? So 3/4 times 3 over 1 is going to be 9 over 4, which is the same as 2 1/4. This one worked really well. It's the only one that worked really well. 5/6 divided by 3 over 2, times 3 over 2 is going to be 15 over 12, which is going to be 1 1/4 when simplified down. 7/8 times 4 over 3 is going to be 28 over 24, which is going to be 1 4/24, which is going to be 1 1/6 when simplified all the way down. Okay. Activity 3.4, multiply by the reciprocal, which is what we've been teaching you. When you reverse the numbers in the numerator and denominator of a fraction, you form a new fraction called the reciprocal of the original fraction. Which number is its own reciprocal? 1. Because 1 over 1 would be 1, and its reciprocal would be 1 over 1. Okay, you flip the 2, it'd be the same. The numerator and denominator are the same. It doesn't matter which one. If it's 2 over 2, my reciprocal is going to be 2 over 2. Okay? And so the reciprocal, it's its own. Which number has no reciprocal? Explain your reasoning. 0. Because if I had 0 over 1, my reciprocal would be 1 over 0, but I can't do that. That's a no-no. If I take my calculator and I take 1 divided by 0, it comes up as impossible. Okay? On the right-hand side here, the reciprocal of a number is also known as the multiplicative inverse of the number. The multiplicative inverse of a number a over b is the number b over a, where a and b are non-zero numbers. The product of any non-zero number and its multiplicative inverse is 1. The multiplicative inverse property states a times b, a over b times b over a equals 1, where a and b are non-zero numbers. So basically, what we're going to do on the next slide will show some of these. So Alexa wrote the reciprocal of the mixed number incorrectly. Explain why she is incorrect and provide the correct reciprocal. So Alexa said, given this 3 and 8/5, the reciprocal is 3 and 5/8. She didn't put the whole number in, okay? So she didn't use the whole number. She forgot the whole number. Since she forgot the whole number, I need to turn it into an improper fraction first. So I would take 3 and 5/8 is going to be equal to whole number times the denominator plus the numerator equals the new numerator over the original denominator. And then the reciprocal is going to be 8/29. Because when I multiply those out, I'm going to get 1/1. I'm going to get 1. Karen said, I wish everything could be as easy as dividing by 1. She tried her dividing by 1 method to determine the quotient 5/8 divided by 3/4. If I can turn the divisor of 3/4 into 1, then the problem can be solved. I can multiply both fractions by the reciprocal of 3/4, which is 4/3, to create 1. Analyze Karen's method for dividing fractions. Describe the steps in the dashed circles. Okay, so this is just showing why I can multiply by the reciprocal. And so in this first one, I took this division problem, 5/8 divided by 3/4, and I wrote it as a complex fraction right here. This is a complex fraction. Okay, and they'll be showing you more of those next year. Then in this next step, I multiplied them both by the reciprocal. Okay, and that's just to make it so the denominator is 1. All right, and so here is showing how the denominator equals 1. Okay, and then that leaves us just with what's on top, which gives me 5/6. Okay, so write a rule based on Karen's method that you can use to calculate the quotient in a fraction division problem. Basically, you multiply the dividend, the first one, by the reciprocal of the divisor. That is the correct math lingo for what we've been doing, which is keep, change, flip. Calculate each quotient. Well, this would be 5/6 times 4/1, which equals 20/6, which is going to be equal to 3 2/6, which is equal to 3 1/3. This would be 4/5 times 3/1, which is going to be 12/5, which is going to be 2 2/5. This is going to be 1/8 times 2/1, which is going to be 2/8, which is going to equal 1/4 in simplest form. This is 3/10 times 3/1, which is going to be 9/10, and that is in simplest form. Activity 3.5, dividing with mixed numbers. Let's consider how to make a bag of trail mix that has a weight greater than 1 pound. If you have 5 2/3 pounds of trail mix, how many bags can you make so that each bag contains 1 5/6 pounds? Analyze each student's method. So this is Carla. It's got a thumbs up, which means it's correct. She first drew a model for 5 2/3, 1, 2, 3, 4, 5, and then 2/3. Then I knew that I needed 1 5/6 groups, so I divided my model to show 1/6. How did she know that she needed 1/6? Because she was dividing by 1 5/6. So she knew it was broken up into sixths. So she broke up the whole thing into sixths. All right, and so we have them now full into sixths, and then she's making groups of 11/6. She got 11/6 because 1 5/6, 1 times 6 is 6, plus 5 is 11, 11/6. And so she put circles around the full groups. And then she has one part left over, okay? And the remaining 1/6 of a part is actually 1/11th of a group. Whoa. There is 11 of these that make up a group. And since there was one part left over, it's 1/11th of the next group. And so she is able to make 3 and 1/11th bags of trail mix. Okay. Then on the back side, we have Karen. And Karen is the way that I have been teaching you this, so it's a thumbs up as well. And Karen wrote a division sentence here and then converted both mixed numbers to improper fractions. So she had 5 2/3 divided by 1 5/6. 5 times 3 is 15 plus 2 is 17 over 3. 1 times 6 is 6 plus 5 is 11 divided by 11 over 6. Then in this part, she reduced the fractions before she multiplied. It makes it easier. We haven't really gone over that here. Then she multiplied. 17 times 2 is 34. 1 times 11 is 11. And that simplifies down to 3 and 1/11. So I can make 3 and 1/11th bags of trail mix. Okay. And so this is the way that I've been going through, turning them all into mixed numbers, then keep, change, and flip. Karen converted the mixed numbers to improper fractions. How did Carla represent this same step? Carla, on hers, divided the model into sixths. Okay, and then she circled 11/6. She circled groups of 11/6. Okay, so when she divided it into sixths, she basically got 34/6 for 5 2/3, and then she got 11/6 when she did her groups. Okay. Describe how Karen changed from division to multiplication. Karen took the reciprocal. She took the reciprocal of the divisor. And then multiplied. Solve each problem, show your work, and be sure to label your answer. The cook in the school cafeteria made 47 1/2 cups of mashed potatoes. If there are 1 1/4 cups of mashed potatoes in a serving, how many servings did she make? Okay, 94 plus 1 is 95, 95 halves, divided by 45, 5/4. 95 halves times 4 over 5. Multiply that out. I would get, let's see here, 0, 2, 380 over 10. That simplifies down to 38 servings. One of the most beautiful hiking trails in the United States is Glacier Gorge in Rocky Mountains National Park. The hiking trail through Glacier Gorge is 9 3/5 miles round trip. If you hike 1 3/5 miles an hour, how many hours will the round trip take? So we're taking 9 3/5 and dividing it by 1 3/5. First, I put these as improper fractions. 9 times 5 is 45, plus 3 is 48 fifths, divided by 1 times 5 is 5, plus 3 is 8 fifths. Then I rewrite it, 48 fifths times 5 over 8. Then I would get 40. So 240 over 40. And then I'm going to get 6 hours, holy cow, of hiking would be my final answer for this one. Okay. Talk the talk, going almost numberless. Complete each statement with greater than, less than, or the same as. If a quantity greater than 1 is divided by a value between 0 and 1, the quotient will be greater than the original quantity. When I'm solving this, I would take, let's see here, I would take 2, and then I would, the quantity divided by the value between 0 and 1, I would divide it by 1/2. If I divide this by 1/2, then I'm actually going to get 4, and that's greater than the original quantity. So when I'm doing these, I'm going to try to put numbers in to see what it says. Okay. If a quantity between 0 and 1 is divided, so between 0 and 1, 1/2, is divided by a value greater than 1, so let's go 2. All right, and so this would be 1/2 times, and so this is going to be less than the original quantity. Okay. C, if a quantity between 0 and 1/2, or 0 and 1/2, is divided by a value between 0 and 1, so divided by 1/2, the quotient will be what? All right, so this would be 1/2 times 2 over 1, which is going to be equal to 2 over 2, which is going to be equal to 1. So that is greater than. So this should be greater than. And so I want to put numbers in to see what is correct. 2, complete each statement with always, sometimes, or never. If a mixed number is divided by another mixed number, the quotient will sometimes be greater than 1. Okay? So if this one, if it's 5 and 1/2 divided by 2 and 1/2, then my answer will be greater than 1. But if it's 2 and 1/2 divided by 5 and 1/2, then my answer will be less than 1. So sometimes it's greater than 1, sometimes it'll be less than 1. B, if a fraction between 0 and 1 is multiplied by another fraction between 0 and 1, the product will be less than 1. So if a fraction between 0 and 1 is multiplied by another fraction between 0 and 1, the product will be less than 1. I think that's going to be always. Okay, taking a part of a part, and so my answer is going to be a smaller part. C, if a whole number is divided by a fraction between 0 and 1, the quotient will be always, sometimes, or never. Let's see. A whole number, 2, is divided by a fraction between 0 and 1. The quotient will be, let's see here, 2 times 2 over 1 equals 4. Will never, it's going to be bigger, less than 1. Last, if a fraction between 0 and 1 is multiplied by a mixed number, the product will be greater than 1. Okay, so if I take half of, let's see here, 1 and 1/2, so it's half times 3/2, that's going to be 3/4. 3/4 is going to be not greater than 1, so it's not going to be always. Then if I took, let's see here, if I took 3/4 times 3 and 1/2, that would be 3/4 times 7/2, which is going to give me 21/8, which is going to be greater than 1. So it is sometimes going to be greater than 1, and sometimes it will be less than 1. Okay, and so when I was trying to figure these out, I used number examples to prove if I was right or wrong for each of these. So I should write these down along with the greater than, less than, as well as the sometimes, always, never. Okay, I want to have proof of these. Consider the quotients 5/6 divided by 1/2 and 5/6 divided by 2. Okay, so first, 5/6 divided by 1/2 is the same as 5/6, which is equal to 10/6, which is equal to 1 4/6, which is equal to 1 2/3. Okay. 5/6 divided by 2, 5/6 divided by 2 is going to be the same as 5/6 times 1/2, which is going to be 5/12, and 5/12 is right there. Okay. So greater than 1, and then less than 1. We had a real world problem that can be solved using each division. Okay, so I had 5/6 cups of raisins and wanted to see how many half cup servings I could make for my snack. Okay, so that's that one. Let's see here. I have 5/6 of a cup of popcorn and want to divide it into 2 equal groups. Okay, and so trying to figure out what the numbers would go with it, what would make sense for the problem, and I know cups of food kind of works for this.